In these last two examples, we're asked to find a z-value such that 0.9282 of the area lies between two z-scores or z-values, a negative one and a positive one. Okay, so in this type of problem, you're still needing to remember that the area under the normal distribution curve is equal to 1, or we sometimes think about it as 100%. We talk about the area under the curve, and we also talk about the probability. So the area under the curve is the probability. So they're wanting to know what's the z-score, what are the two z-scores if we're looking for the area between them, and that area is 0.9282. What are these z-scores? Okay, so here I've just drawn the diagram. This part is just the part they already told us, that we have a negative z and a positive z. So these are going to be on opposite sides of the zero, opposite sides of the mean, and they're going to be the equal distance from the zero. So whatever we find negative z to be, z is going to be that positive number. Okay, I've already worked it out here, but now I'm going to show you how. Okay, so we're going to start here. Since we can only use the table to find the area under the curve to the left of a z-score, we're going to need to think about what is this area under the curve. And how I did this was I took 1 minus the area under the curve that they gave me in the problem, and that told me how much of the area under the curve was left. Okay, then I took that value and I divided it by these two pieces. That told me the area left under the curve in both of these places. Okay, so then I'm needing to find the z-score associated with this area. Again, we can only do that when we're working with a z-score and going to the left. So that's why we needed to find this area or this probability. Now we can use this and look it up in the table and find this score. And that's what I did here. I used table A, and remembering that all these little numbers inside the table, these are your probabilities or your area under the curve. These on the side and across the top, those are your z-scores. So this time we're given the area, 0.359, and we're looking for that, and there it is exactly. So to find its z-score, you're going to the left to get negative 1.8, and up is just 0. So for this area under the curve, the z-score is negative 1.80. Once you've calculated that, you don't have to do anything else because your positive z-score is going to be that value, but positive. Okay, so let's look at one more example of this. This time, it's basically the same. They're just giving us some probability, and they want to know what are those z-scores that probability is between. So this is just information they already gave me, and I'm needing the negative and the positive z. Again, these are the same distance from 0. So we really only have to find this negative one, and we're going to do it in a similar way. First, we're going to do 1 minus the probability that they gave us in the problem, and that's going to give us the rest of the area under the curve. Then I'm going to divide that value by 2 because I have 2 pieces here. And that's going to tell me how much the area is for both of these. Now, obviously, these should have exactly matched in size, but it doesn't really matter just for us to fill out our calculations. Okay, so when I get my divided value, now I'm using the table to find out what is the z-score associated with this probability. And I find it to be, so again, I'm just looking for 0, 4, 4, 6. And it also comes out exactly evenly. 0, 4, 4, 6. So that's negative 1.70. Negative 1.70. That's this z. And then our positive z is just the positive 1.7.